Next problem in single proportion test, right? First problem, your researchers claims that a particular party will win in next election. A statistical data reported that 23% voted for that particular party in last election. To test the claim, a researcher surveyed 80 people and found 22 said they voted for that party in last election. Is there enough evidence at alpha is equal to 0.05 to support this claim? So one person is checking the vote polled for the one particular party, right? One political party, right? So he is telling, based on that he is telling in the next election that particular party will win. So what the statistical data is having, so the 23% of percent voted for that particular party in the last election, right? So from that report, statistical report, so out of 100, 23% voted for that particular party. To test the claim, researchers surveyed, so for that, for this one, so here in that particular researcher, the particular person checking that, so he asked 80 people and found 22 said voted for that party. Out of 80, 22% said yes, we have voted for that particular political party. So now we have to check this is enough evidence, this is true at significant levels 0.05, that is 5% level, to support this claim. So the claim is true whether the party will win on the next election with that evidence, right? So we'll check that. Given sample size, so he surveyed 80 people, so small n is equal to 80. So x be the number of person voted for the given party, so x be the is the number of success in this case, right? So given that out of 80 people, 22 said they voted for that party, so number of success means 22 they voted for that particular party. That means, so out of 80 you are having 22, that is here x is equal to 22, n is equal to 80. So proportion, what is the proportion? Proportion means percentage, that's all, right? Small p is equal to x by n. 22 by 80, well, that is equal to 0.275. so probability of success, so probability of failure, q is equal to 1 minus p, 1 minus 0.275, that is equal to 0.725, right? Now we are going to define the hypothesis. Null hypothesis H naught is 23% voted for that particular party. We are accepting that statistical data, right? So population proportion p is equal to 23%, capital P. Alternate hypothesis p not equal to 0.23. 23% means at 23 by 100, 0.23. So p, capital P, is equal to 0.23. So alternate hypothesis capital P not equal to 0.23. So we are using two-tailed here, right? Now failure, q is equal to 1 minus p, that is equal to 1 minus 0.23, that is equal to 0.77. Now test statistics, z is equal to small p minus capital B by root of capital PQ by n, that is the formula. We are substituting the values 0.275 minus 0.23 divided by root of 0.23 into 0.77 by 80. So you will get 0.95541. Calculated value of z is 0.95541. Tabulated value at 5% level, alpha is equal to 0.05, they have given is 1.96 from the table. Now we are going to conclusion. So calculated value 0.95541 is less than the tabulated value 1.96, therefore H naught is accepted. So definitely the party will win in the next election. We can accept the claim. Next problem. A random sample of 500 apples was taken from a large consignment and 60 were found to be bad. So there are 500 apples in a big room, right? in that 60 found to be bad. That is, we cannot use that rotten, right? Found to be bad. So obtain 98% confidence limit for the percentage number of bad apple in the consignment, right? So we are going to find the confidence limit. Yes, 60 is bad out of 500. So what is the confidence limit? 98% confidence. Yes, definitely for a whole lot it is true. So what is the confidence limit, right? So we are going to find that limit in between. Definitely in between the confidence will be, right? So given a random sample of n which is equal to 500 apples, x be the number of bad apples, that is the number of success in this case, right? So x is equal to 60. So out of 500, 60 were found to be bad. So small p is equal to x by n proportion. So 60 by 500, so 6 by 50, that is equal to 0.12 success, right? Failure, q is equal to 1 minus p, 1 minus 0.12, that is equal to 0.88. So required confidence interval formula, small p plus or minus z root of pq by n, right? Here z is 98%, right? Z alpha, z value, right? We are going to take that value from the table. Z is equal to 2.33. Then substituting all the values, the confidence interval is 0.12 plus or minus 2.33 into root of 0.12 into 0.88 by 500. So you will, after simplification, you will get 0.12 plus or minus 0.03386. First take the minus value, that is minus means 0.12 minus 0.03386. There are two values, plus or minus. First take the minus value, then that is the lower limit, 0.12 minus 0.03386. That value is 0.08614, right? Lower limit. Then take the plus value, 0.12 plus 0.03386, that is 0.15386, that is the upper limit. This is the confidence limit, 98% confidence limit. So approximately 0.086 comma 0.154. So in the percentage, so into 100, so they are asking 98% confidence limit for percentage number, right? So that is why we are multiplying with 100. So 8.6% to 15.4%, that is the percentage, right? Within this the bad apple should be, right? So bad apples should be out of 500, see lower, at least bad apple should be 8.6%. Maximum bad apple should be 15.4% in that lot. If you are taking any lot, this is the confidence interval, right? Thanks. Next problem. 20 people were attacked by a disease and only 18 survived. Will you reject the hypothesis that the survival rate, if attacked by this disease, is 85% in favor of the hypothesis, that is that it is more at 5% level? Given sample, so they are taking 20 people were attacked, so sample size n 18. So number of survived, that is the number of success. So x be the number of survived people, x is equal to 18 they have given. Out of 20, 18 survived. So proportion you can directly write p is equal to x by n, that is equal to 18 by 20, that is equal to 0.9, that is probability of success. Failure 1 minus p, that is equal to 1 minus 0.9, that is equal to 0.1. Now next we are going to define the hypothesis. Hypothesis H naught. So they are asking 85% favor of the hypothesis. So we are taking the hypothesis as it is, 85% survived from the disease. So H naught is population proportion, p is equal to 85%, that is 85 by 100, that is equal to 0.85. Then alternate hypothesis H1. So just to take opposite to null hypothesis, p not equal to 0.85, right? So two-tailed, maximum we are using two-tailed, right? That is safe side. Otherwise you have to check whether that is you want increase amount or decrease amount. According to that you have to use left tail, right tail, right? So that is why we are taking two tails on the maximum number of problems. So two tail test. So or you can take more than that, means you can take p greater than 0.85. that is what I told you, right tail test. So you have to check carefully and take the right tail test, right. So q is equal to 1 minus p, that is equal to 1 minus 0.85, that is equal to 0.15. Now we are going to write the test statistics. Test statistics z is equal to small p minus capital B by root of pq by n. If you know capital P, you take capital P in denominator, pq by n, right? So in the previous problem we are having small p only, right? That is why we have taken that confidence interval formula, root of small pq by n, right? Note that. If you are having capital PQ, then you have to write capital PQ. So substituting the value 0.9 minus 0.85 by root of 0.85 into 0.15 by 20. So you will get 0.6266. So calculated value of Z is 0.6266. Tabulated value at 5% level 1.96. Now conclusion, right? So conclusion, calculated value is less than tabulated value. Therefore H naught is accepted. So P is equal to 0.85. So their claim 85% survived. That is true. Favor of hypothesis, that is more, right? Using right tail we can check for the right tail. So you can use any one of the ideas, right? So I am solving both right test, or two tail test and right tail test. You can take any one of this. Tabulated value of Z up to that one, tabulated value, that is calculated value Z test statistics is same for both, right? So Z value is 1.645. So from the tabulated value we are taking, because when you are using right tail 1.645 tabulated value, but in the two tail test Z value is 1.96. Note that we have to change the values according to that, right tail, left tail or two tail, right? So conclusion, now we are up to test statistics both are same, I already told you. So we are taking calculated value as same, 0.6266, right? Now tabulated value will change, that is 1.645. In this case it is greater than tabulated value also. Those in this case also H naught accepted. Sometimes we will reject H naught, right? The both cases will differ, right? Sometimes, right? So P is equal to 0.85 is accepted. Thanks.